these modules might be doing for you in terms of the end-to-end task isn't always representative of what they are doing, and I'll talk about that a little bit more later. And lastly, the downstream modules of these systems are dependent on the quality of the output of earlier modules. So what tends to happen is you'll annotate data for the downstream models, and meanwhile you've got somebody down the hall who's changing the input modules. And by the time you're annotating your data, it's no longer representative of the input that the module's getting. So the keys become quickly obsolete in any kind of realistic development setting. Now, despite those drawbacks, people have done this kind of learning for modules of their system. And what you end up seeing is the closer the task is to the text characteristics of the text, the better your modeling is. So, for instance, BBN has a Markov model-based system for doing name recognition that's only a couple points under the best hand-coded systems for all intents and purposes. It's fully competitive, and it has a number of other advantages in terms of portability and so forth. Pattern recognition, it gets a little more murky. Generally, nobody's been able to robustly learn patterns in a muck-like setting. They've either had to they've either had to address a much simplified task, or have some human in the loop that goes through and filters out by hand patterns that are learned by the system. It's tough to find a general comment to make about work in co-reference. These three works here are quite different, but they all have somewhat limited scope, and while they can be shown to improve and make different assumptions, but while they can be shown to improve certain baselines, they haven't had a lot of payoff in terms of the end-to-end system. So again, the more we get into kind of higher levels of linguistic processing, the further we are from the text, and the less competitive the automatically trained systems are from the hand-developed systems. Okay. Despite all that, I focus my attention on this discourse level mechanism, this merging process that I described before, which essentially seeks to find cases in which you have event descriptions that are actually partial descriptions of the same complex of events. And it's a crucial process to do in an information extraction setting where you need to represent the right number of events in your output. Now, this is the crudest possible approximation to a task that actually people use a lot of inference and knowledge to do.